Welcome back to our discussion here from the floor of the Detroit Auto Show. And joining me right now is Tom Mathis from TARDEC. And I don't know all the letters of what TARDEC stands for, so please explain to the audience, Tom.
Tank Automotive Research Development Engineering Center. We are, in fact, Department of Defense's Center of Excellence for ground vehicles, manned and unmanned.
So I'm sure a lot of viewers are going, McElroy, what are you, crazy? What do you mean, bringing military people on at an auto show? Explain why TARDEC is at the auto show.
Well, if I take you back in time, in 1941, TARDEC was invented largely for the fact of supporting the manufacturing and leveraging the manufacturing expertise that resided in Michigan. And now TARDEC, and the reason why we're at the auto show, is we're leveraging the research, development, and intellectual capital that resides within this fair state. Being able to tap into the industrial and academic power that resides in Michigan is why we're here. And
you've got an exhibit here at the Detroit Auto Show, right? And you've got a couple of vehicles here. Tell us what you've got.
Well, we've got a clandestine vehicle which is looking at a systems perspective of taking hybrid electric, advanced lithium-ion batteries. It deals with innovation that we've done with transmission work with local firms. It also looks at our autonomous vehicle demonstrator that we've got. If you look at the way, shall we say, remote control aircraft has changed combat and taken...
With the drones that we read about in Afghanistan
and elsewhere. It's taken pilots out of harm's way. The autonomous vehicles basically are going to take soldiers out of harm's way and going into areas to reconnaissance, to get information, etc. And if we make it autonomous, we're bringing the power that resides with electronics, sensors of that and that. We've also got a capability that deals with power conditioning, because as you go to the need for more and more power, which we have with all of our sensors and detection devices, we need to be able to condition that power. And how we're able to use Next Energy to develop that capability with whether it's AC or DC to get it in for the network, the installation, our forward operating bases, giving the soldier the power they need is critical. We're also showing and partnering with Oak Ridge National Lab, which is basically out of the Department of Energy, because if you bring the power that their laboratories have with ours, you basically take 2 and 2 and make 6. So doing that with the intellectual capacity that resides here is really why we're here.
So if I got that right, you have a reconnaissance vehicle that you're showing and an autonomous
We've got a demonstrator of what it is, because currently it's in test. It's a 10-ton vehicle that goes 50 miles an hour, will climb a 3-foot step, and it's totally autonomous.
That is unbelievable. And when you say autonomous, you don't mean somebody's sitting back in a center with a joystick driving it.
No, it's got a route that it needs to go to. It senses, it identifies, it adjusts. It's not telewire. It's not like your child's little remote control with a radio transponder. No, it's totally autonomous.
Why did you choose the auto show to exhibit?
Well, the reality for coming down in here is the fact that no idea, small or large, is beyond what we need to get our warfighter. So as we look at the issues that today's automobile makers have, power, fuel cells, hybrids, are things that we are investing in, and quite candidly, a lot of our partners up here, Chrysler, Ford, General Motors, are investing probably tenfold what we've got into it. So what we can learn by their investment and bring it to the soldier is really important to us and important to the taxpayer.
Are you hiring people here out of the auto industry?
We've hired last month probably about 186. Wow. We're looking at hiring another 186 to 200 because of the developments that we're doing in alternative energy, storage devices, vehicle electronics and components to upgrade the capability of our systems that have progressed over the last 20 or 30 years. Today's Humvee is not your father's Jeep.
Yeah, you need a whole new generation there, a vehicle, don't you?
Well, when I started working for TARDEC about 29 years ago, 86% of our folks were mechanical engineers, and now we're looking at about 40%, 46% is mechanical. Electronics, computer engineers, chemical engineers, software engineers, every du jour that you can think of is coming in, because the nature of how our systems perform and where we're going to go with biofuels, synfuels, synthetic lubricants, all drive a different intellectual need to solve that problem effectively.
Are you able to recruit the talent that you need in the Southeast Michigan area?
I would tell you that this is a gold mine of intellectual capability that resides within this particular area. Not only what the universities produce, because they tailor to the automotive needs, but those folks that have been, shall we say, impacted by the first-tier OEMs, etc. We're able to draw on people with a wealth of experience. They're able to come in running rather than having to train them on what we do. I mean, if you look at it, a military system is 70% automotive related, at least for ground vehicle systems. So what you would see on a typical Challenger would apply in concept for driveline, propulsion systems, to what we're doing. You know, what we're taking with crush zones and crash resistance is how we're applying that same tools to basically blast impact. So there's a lot of synergy that goes along with it. There's a lot of bright people that are available. We're trying to get them and help our warfighters as we speak.
What's your sense of how military vehicles go then? Will they be going electric? Will they be hybrid? Is it going to be fuel cell, or is it just going to be improvements on the internal combustion engine?
Yes.
All of the above, eh?
Well, and the reality is the fact that we have an insatiable need for power right now, because the threat that our warfighters face varies. Let me just take you briefly through a Humvee. When we first started out, it had a 60 amp alternator. Then it went to 100. It went to 200. It went to 400. It's at 565, and it's going to go to 10 kW.
Why the need for so much voltage?
Well, because of the premises that as we add for radio, identifying blue force tracking, good guys, bad guys, jammers, detectors, defeat mechanisms, we put it on the vehicle in order to provide additional capability. So as a result, the power demands go up, thermal demands go up, power management goes up, new skill sets, new tools, new techniques. How do you condense it? How do you reduce the threat? As I was talking to an individual just a little while ago, we have air conditioning on the vehicles. It's really not to chill the warfighter, because there's only two ways they get the air, through their neck and through their sleeve. We're chilling the electronics, because that's the main thermal demand when 120 degree ambient temperature, 140 degree soak. Electronics don't like heat. So what you look at different means of insulating, different ways of managing it, and condensing it into a smaller space is critical. Reducing those thermal and power demands are essential.
So Tom, where does TARDEC go from here? Where do you see it going in the next decade or so?
I would expect that we're going to be looking at alternative energies, because as we reduce our demand on foreign and fossil fuels, we'll be looking at biofuels, algae fuels. How does that impact today's diesel engines? Particularly, we're a single fuel that has high sulfur with our JP8.
JP8, of course, being the fuel that the military uses just about across the board for all land vehicles, right?
It runs the aircraft as well.
Does it really?
It's a single fuel. So the commercial engines tend not to like high sulfur. When you go to the biofuels, what's the impact that goes on that? As we look at the power demands, how do we get better energy storage? Lithium ion, advanced lithium ion. Now granted, the vehicles that you'll see with your hybrids here aren't quite the ones that we put them through where we go to.
You have a different driving cycle, do you?
We have a different duty cycle, we have a different environment that we take people into, and the real question is if we take a look at that and the solid state stuff that we go to, is how do we package it smaller? How do we make all of the components that we put into it work off a single processor, so there are single cards that they put into it. So we're looking at the software demands, we're looking at the electronic demands, thermal, power management, storage devices, and more specifically driving the modeling and simulation that allows us not only to do the 3D geometry, but all of the analysis functions that you see at a Roush, Ricardo, etc., because there's a lot of smart people trying to solve the same problems.
Let's talk about biofuels a moment, because that's a topic that's near and dear to my heart, and especially the algae fuel. Yeah. How's that coming along?
We currently have 3 engines in test right now. The Air Force has got the lead with respect to how they're integrating it, but we're looking at assessing them with respect to their performance at a system level, because it impacts, more specifically, how does the combustion cycle work? What does it do to the pistons and to the valves and all of the components that lead to it with respect to the fuel pumps, And then more specifically, as we understand that, how do we store it, distribute it, and transport it? And how do we mix it? Because as our helicopters, because like I said, we have a single fuel. We have helicopters that work off of it, we have generator sets that work off it, and we have vehicles that work off on it. Assessing that impact so that we don't have a soldier who has an issue when it gets into harm's way. And the next one is, because we're in a variety of different theaters right now, we're in about, I believe, 230 places in the world. When we go for the fuel, how do we make sure that it's distributed worldwide and we don't have a jet fuel in one place and synthetic fuel in another, and that all synthetic fuels are within the same performance envelope and specification with lubricity, etc.
So you're still in a learning stage.
We're still in the learning part. We're validating it on the system so that we understand it, so we can articulate those particular requirements to our engine manufacturers, so what we need, and understanding the logistics impact that we have, because there's three things that impact our logistics capability. They call it the logistics tail when you go into war. It's bullets, it's fuel, and it's water. And when you look at the massive amounts of fuel that we have, i.e. a Humvee gets 4.2 miles to the gallon, and you look at that, we're considering millions of gallons of fuel that we consume.
Mm-hmm. So, but again, gut feel, how does the algae and biofuel look?
I think that where we're going to go to is we're going to go to a biofuel probably about 5 years down the line. We'll get into it significantly. Because of the fact that the Air Force consumes a lot, they're certifying their birds on the biofuels. I think that we'll go to a blend, and then it gets into demand and cost. Because the President's budget is based on, right now, the price of crude per barrel. And if it gets over $75, it impacts our ability to buy equipment and support our troops.
Real good. Well, Tom Mathis, thanks so much for coming in and bringing us up to
pleasure.
date. What TARDEC's all about and why it's at the Detroit Auto Show. That's got to be unique for an auto show to have an exhibit like yours.
And the key is that there's no idea too small or big. So if someone's got one, come online and let us know.
Okay, anybody working in the auto industry now, whether you're looking for a job or have got an idea.
Either way.
Yeah, give TARDEC a call.
Appreciate it.
Tom,
Thank you.
thanks very much.
Appreciate it very much.
You bet.